Today's topic is time domain analysis. We are in second unit of LCS. So, time domain analysis. What are the topics we study? Different test signals. Then, what are the errors for these test signals? Then, step and ramp response of first and second order system. Test signals and error constants. Third, proportional derivative integral PI, PD, PID controllers. So these are the topics we study in this second unit. It is very interesting, easy also. So any system so what we apply? Input. We apply input. So system will give output. This output contain transient plus steady state. What is coming first is transient. After transient to die out, what we get is steady state. Transient is a term which die out at t equal to infinite. Steady state is a term which remain even at t equal to infinite. We can't avoid transient because of system contain inductor and capacitor. As long as inductor or capacitor are there, you can't avoid transient. Resistive network, no transient. But if any one or both are there, transient will come. This transient we need to control. So which is changing with time. How fast it should change. Transient should die out fastly. So the behavior of the transient we need to control. That's why. So control system subject. So basically we are controlling the transient behavior. So we are designing a system such a way that whatever way we want, accordingly transient system will come. Steady state, after transient die out, anyway we get steady state. So this any system we test how system is behaving, how system is working. We analyze with the help of the inputs. What are the different inputs? They are called as a test signals. Testing means testing the performance of the system with the help of different inputs. The first input is step input. How it is defined? R of t is equal to U of t, unit step. R of s is the Laplace of input. Inverse will be R of t. So it is input. Unit step is equal to 1 for t greater than 0 equal to 0 for t less than 0. What is Laplace of this? Is simply 1 by s. How the unit step plot? Like this. So this is r of t is a u of t. So unit step plot, symbolically how it is defined, its Laplace transform. The second test signal is ramp. It is defined like this: r of t is equal to t u of t is equal to t for t greater than 0 equal to 0 for t less than 0. So ramp function. What is Laplace of this? Is 1 by s square. 1 by s square. Now we can plot ramp is like this. This is r of t ramp. The third test signal is parabolic. So that is r of t is equal to basically a t square, parabolic function. But in this subject generally we take 1 by 2 t square. We take a as 1 by 2. So this is equal to this is equal to 1 by 2 t square t greater than 0 equal to 0 for t less than 0. What is Laplace of this? 1 by 2 t square is 2 by s cube. So we'll get 1 by s cube. So 1 by s square, 1 by s cube. To bring into that format, we are taking a equal to 1 by 2. So what is the plot of this? Is like this. So parabolic. Out of all these three, step is very powerful test signal. Why step is powerful? Input is changing suddenly. Its value is 0 up to 0 minus. Its value is 1 from 0 plus. Set 0 undefined. Suddenly changing. Any time signal which is changing suddenly, it contains all frequencies. So testing the system with the step is equivalent to testing the system with all frequencies. That's why step signal is powerful test signal. Second priority is ramp. Why is ramp second priority? Linearly increasing. Na? So we are testing how system responding when signal is changing linearly, whereas here suddenly. Further, least preference is this. Initially slowly rising, later it is increasing fastly. So So among all these three, step is the highest powerful test signal, second priority, third priority. So these three we are using to test the system. That's why they are called as a test signals. Next we'll study error constants. Error constants. So why error is coming, how to analyze error constants and so on is something interesting. So we have a system like this. So this output is C of S, H of S. So this is error E. This feedback signal is B. B of S, E of S, R of S, G of S, H of S. So what is the error here? Error equal to R minus B. R minus B. B equal to H into C. What is C? G into E. So if you bring this side, one plus GH equal to R. Therefore, E by R equal to 1 by 1 plus GH. This is called as error transfer function. Error transfer function. Error transfer function. So this error we have to find. So what is error? E of S equal to R of S by E of S equal to R of S by 1 plus G of S, H of S. So this is the error function. Now we want to find the steady state error. What is steady state error? E of t or otherwise ESS. Steady state error is equal to limit S tends to 0 S into E of S. This is using final value theorem. Using final value theorem. So this you studied already in Laplace transform. So we want to find a steady state error. Steady state error with a step. So what is the steady state error with step? Limit S tends to 0 S into E of s. E of s equal to this. But with the step, what is R of s? 1 by s. 1 by s by 1 plus g of s h of s. So ss cancel. You will get 1 by 1 plus limit s tends to 0 g of s h of s. What is the short form? 1 by 1 plus kp. 1 by 1 plus kp, where kp is equal to limit s tends to 0 g of s h of s. This kp named as proportional error constant. Proportional error constant. So when step is applied, how to find a steady state error? Using formula 1 by 1 plus kp. What is kp formula? Limit s tends to 0 g of s h of s. So like that you can find proportional error constant. This is with the step input. If I change the ramp input, second one is ramp. With the ramp input. So what is the formula? Steady state error equal to limit s tends to 0 s into e of s. E of s is this now. So what is R of s? 1 by s square by 1 plus g of s h of s. So 1s cancel and this s will come here, s equal to 0, so this is 0. So what you get? Limit s tends to 0 s into g of s h of s. This is, we call it as kv. Where kv equal to limit s tends to 0 s into g of s h of s. This is kv. What is the name of kv? Velocity error constant. V for velocity, P for proportional. So whenever ramp is applied, you have to use which formula? Steady state error formula 1 by kv. Kv equal to this. This is not 0. Don't substitute s equal to 0, therefore 0. No. It depends on g of s h of s. If g of s h of s is 1 by s, ss cancel, it will become 1. So you can't simplify this directly. It depends on g of s h of s. So we are trying to find steady state error with the different inputs. Then third one, with the parabolic. With the parabolic. So steady state error equal to limit s tends to 0, s into, what is parabolic? 1 Laplace is 1 by s cube by 1 plus g of s h of s. So 1 s cancel, s square, s tends to 0, this is also 0. It is simplified to limit s tends to 0, s square g of s h of s is equal to 1 by Ka. So what is Ka formula? Ka equal to limit s tends to 0, s square g of s h of s. This is Ka formula. This Ka named as acceleration error constant. Acceleration error constant. So that's why we are studying under topic of error constants. So what are the error constants? Kp, Kv, Ka. They are named as error constants. When we use this formula, if input is a step. When we use this formula, when input is a ramp. When we use this formula, when input is a parabolic. With the step, what is the steady state error formula? 1 by 1 plus Kp. With the ramp input, what is steady state error formula? 1 by Kv. With the parabolic, what is steady state error formula? 1 by Ka. So error constant depends on type of input we are applying. So these are the three test signals. Depending on the input, corresponding formula we have to use it. Let us solve a problem. One example. Given gh equal to 10 by s into s plus 2. Find all error constants. Find all error constants. So what are the error constants? First one, Kp. What is Kp formula? Limit s tends to 0, gh. Limit s tends to 0, 10 by s into s plus 2. So when s equal to 0, what is its value? Infinite. Similarly, Kv. Limit s tends to 0, s into gh. Limit s tends to 0, s into, what is g of s, h of s is 10 by s into s plus 2. One s cancel, s equal to 0, you will get 5. You will get 5. Then Ka. Limit s tends to 0, s square gh. That is limit s tends to 0, s square into 10 by s into s plus 2. One s cancel, but s equal to 0, so numerator is 0, everything is 0. So how these answers looking like? It will be either 0 or infinite or finite value. Any problem you take, answers will be either 0 or infinite or some finite number. Like that it will come. So this is how we can find out error constants for the given problem. What is steady state error? 1 by 1 plus kp. So kp is infinite, you will get error 0. Na? Second case, what is steady state error? 1 by 5. 1 by 5 is 0.2. Third case, what is steady state error? 1 by 0, which is infinite. So error is either 0 or infinite. Error is finite. Error generally it cannot be infinite. That is the one of the drawback of error. Error is infinite means meaningless. Na? So error can be 0 allowed. Error can be finite allowed. Error is infinite is not allowed. This is the drawback of error constants. Okay. So what are the drawbacks or disadvantages of error constants? One disadvantage is, first disadvantage is how error changing with the time we are unable to find. Disadvantages. One is we don't know how error changing with the time. We don't know how error changing with time. In general practical applications, error changes with time. So only the steady state error is coming, but with the time how they are changing, that information is missing in this error constants. So that is eliminated using error coefficients, but that is not there in our syllabus. Second is you can't find error with the sign input. Not possible to find error with the sign input. With the sign input. So if input is a sine wave, applied, what is the output is also sine wave, na? What is the final value of steady state? Don't know. So final value theorem is not applicable to sine wave. So see, if it is increasing or decreasing and reaching some steady state, then you can find a steady state error. Its final value, it continuously waveform is changing. Na? What is its final value? Without knowing final value, you can't find a steady state error. So not possible to find error with the sine input. Final value theorem not applicable to sine wave, because this is having poles on imaginary axis. When poles are having imaginary axis, response is oscillatory. Whenever response is oscillatory, final value not possible, steady state error also not possible. So these two are the disadvantages of error constants. Next to type and order. Type and order. So in general, g of h equal to some constant k by s power l so s plus sigma 1 into s plus sigma 2 and so on. L is the type. L is type of the system. What is the order? Maximum power of S. Maximum power of S is the order. This L is the type of the system. If L equal to 0, type 0. L equal to 1, type 1. L equal to type 2, like that. So maximum power of S is the order. L will tell you number of poles at origin. Number of poles at origin. Order will tell you total number of poles. Order will tell you total number of poles. So for example, if GH is given like 10 by S into S plus 2. So what is the type? S power here 1, so type 1. Type 1. What is the order? Maximum power of S, so order 2. Order 2. Example 2. GH is 5 by S square. Type 2, order also 2. Type 2, order also 2. Third example. 10 by S plus 2. Type 0, order 1. Type 0. Type 0, S power 0, type 0, but order 1. Here how many poles are there at origin? 1. What is the type 1? How many poles are at origin? 2. So type 2. How many poles at origin? 0. So type 0. So type will tell what? Number of poles at origin. And order will tell you total number of poles. How many poles are there? S equal to -2, S equal to 0. So total poles will tell order. Number of poles at origin will tell type. That is the difference. So steady state error depends on, or error depends on, input and system. So whatever error you get in the output, that error depends on input as well as the system. Because depending on the step, we used 1 by 1 plus Kp. If input is a ramp, we used 1 by Kv. So that formula depends on input. And within the formula, GH is there now. So GH is the loop gain system. So system is described with the type and order. That's why error depends on input and also system. Next step response of first order system. So any first order system C by R or C of S by R of S is like 1 by 1 plus S tau. 1 by 1 plus S tau. So it is like this. So 1 by S tau unity feedback C and R. So what is C by R will be? 1 by S tau by 1 plus 1 by S tau. So we get 1 by 1 plus S tau. So what is this GH? GH is 1 by S tau. So first order system. So GH is 1 by S tau. So first order, what is the power of S? Is order. So that's why it's first order system. So any first order system, overall transfer function is this. But what we want with this step, what is the response? So C of S equal to R of S by 1 plus S tau. But what is the step Laplace? So 1 by S into 1 plus S tau. Now we have to find response. So using partial fractions, it is A by S plus B by 1 plus S tau. Now to find A. SS cancel. S equal to 0, you will get 1. You will get 1. What is B? This cancel. 1 by S. At S equal to minus 1 by tau. So you will get to minus tau. Therefore, C of S equal to 1 by S minus tau by 1 plus S tau is 1 by S minus 1 by S plus 1 by tau. Take tau common, cancel 1 by S plus 1 by tau. What we want to response? C of t. Inverse of this is C of t. Step response of first order system. So we get U of t minus e power minus t by tau U of t. So this is the step response. So what is the input we are applying? Input is step we are applying. This is input. If you draw output, 1 minus e power minus t by tau into U of t. So at t equal to 0, it will be 0. T equal to infinite, it is 1. So it is rising exponential. So this gap is a steady state error. So steady state error is a difference between input and output. This is output. This is C of t. C of t. This is R of t. What is here? E of t. So this error is nothing but input minus output. Na? This error is nothing but input minus output. Input minus output difference is error. Steady state at t equal to infinite, whatever you are getting is a steady state error. So error is changing with the time. Whatever error we get in steady state is called as a steady state error. How to find that? What is error signal E of t? Is R of t minus C of t. This is for unity feedback system. So what is input? Is U of t. Input is U of t. What is C of t is this. So 1 minus e power minus t by tau into U of t. So if you simplify, you get e power minus t by tau U of t. This is steady state. This is error function. But what is steady state error? Limit s tends to 0. Steady state error, limit t tends to infinite e of t. So this e of t at t equal to infinite is what? 0. So we are getting, in a time domain approach, steady state error is 0. Graphically also, at t equal to infinite, this is 0, you get 1. At t equal to infinite, this is 1. 1 minus 1 is 0. So graphically 0, mathematically also 0. Using formula. What is the steady state error formula? 1 by 1 plus Kp. What is Kp? Limit s tends to 0, gh na. What is gh? 1 by s tau. So s equal to 0, what is this value? Infinite. If it is infinite, 1 by 1 plus infinite is how much? 0. So using formula 0, graphically 0, mathematically also 0. So that is the concept of steady state error. So we analyzed the step response of first order system. Next to ramp response of first order system. So this will study in the next class.
I know.
So thank you.